A scientific instrument can be any type of equipment, apparatus or device as is specifically designed, constructed and often, through trial and error, ingeniously refined to apply utmost efficiency in the utilization of well-proven physical principle, relationship or technology to facilitate or enable the pursuit, acquisition, transduction and storage of repeatable, verifiable data, usually consisting of sets numerical measurements made upon otherwise unknown, unproven quantities, properties, phenomena, materials, forces or etc., preferably as those characterized over time by an increasing degree of accuracy and precision and, typically, those initially derived as isolated or dependent variable results from, or empirical observations made during, the course of such experimental procedures as are firmly based upon the scientific method and long-accepted tenets of experimental design. Scientific instruments are part of laboratory equipment, but are considered more sophisticated and more specialized than other measuring instruments as scales, meter sticks, chronometers, thermometers or even power or waveform generators. They are increasingly based upon the integration of computers to improve and simplify control, enhance and extend instrumental functions, conditions, parameter adjustments and data sampling, collection, resolution, analysis, storage and retrieval. Individual instruments can also be connected as a local area network and can be further integrated as part of a laboratory information management system, that in addition to having Internet access to databases of such physical properties as compound spectra libraries through the World Wide Web for results comparisons and advanced data analysis as well as the obvious usefulness of now ubiquitous email for rapid exchange of informational text and images, consultation and peer review. Recently, the development have utilized open-source principles borrowed from the software industry to rapidly improve low-cost open-source hardware for scientific measurements and to create open-source labs. Some scientific instruments can be quite large in size, like particle colliders that can be several miles in circumference or radio telescope antennas and antenna arrays used in astrophysics. As you might expect, the converse or nanoscale also has been added to the list of the realm of scientific instrument applications and research, with much of the activity centered on the use of miniaturization in the field of medicine, particularly as non-invasive imaging has exploded on the diagnostic arts and minimally invasive tools and robotics have extended the reach of surgeons of every stripe. In fact, instruments on the scale of a single molecule may soon interact with our bodies at the cellular and biochemical level to collect diagnostic information and provide highly precise medication delivery mechanisms. Scientific instruments can be found on board sounding rockets, satellites or planetary rovers and controlled by radio telecommunication. List of scientific instruments. Accelerometer, physical, acceleration, ammeter, electrical, amperage, current, anemometer, wind speed. Adaptive optics scanning laser ophthalmoscope, retinal imaging, caliper, distance, calorimeter, heat, DNA sequencer, molecular biology, dynamometer, torque, electrometer, electric charge, potential difference, electroscope, electric charge, electrostatic analyzer, kinetic energy of charged particles, ellipsometer, optical refractive indices, gravimeter, gravity, inclinometer, slope, interferometer, optics, infrared light spectra, magnetograph, magnetic field, magnetometer, magnetic flux, manometer, air pressure, mass spectrometer, compound identification characterization, micrometer, distance, microscope, optical magnification, NMR spectrometer, chemical compound identification, medical diagnostic imaging, ohmmeter, electrical resistance impedance, oscilloscope, electric signal voltage, amplitude, wavelength, frequency, waveform shape pattern, seismometer, acceleration, spectrogram, sound frequency, wavelength, amplitude, spectrometer, light frequency, wavelength, amplitude, telescope, light magnification, thermometer, temperature measurement, time of flight mass spectrometer, see mass spectrometry, theodolite, angles, surveying, thermocouple, temperature, voltmeter, voltage, list of scientific instruments manufacturers, 454 Life Sciences, United States of America, AD Instruments, New Zealand, Agilent Technologies, United States of America, Applied Photophysics, United Kingdom Ariel and Company, Beckman Coulter, United States of America, Bruker Biosciences Corporation, Cambridge Scientific Instrument Company, United Kingdom, Horiba, Japan, JOL, Japan, LECO Corporation, United States of America, Malvern Instruments, United Kingdom, McPherson Incorporated, United States of America, MTS Systems Corporation, USA, Mechanical, Novacam Technologies, Canada, Oxford Instruments, United Kingdom, PAL Corporation. United States of America, PerkinElmer, United States of America, Polymer, Spain, Shimadzu Corporation, Japan, Tektron, Melbourne, Australia, Thermo Fisher Scientific, United States of America, Waters Corporation, United States of America, List of scientific instruments designers. Jones, William, Kip, Ptius Jacobus, Le Bon, Gustav, Roelofs, Arjen, Paragraph Nair, Johannes, von Reichenbach, Georg Friedrich, History of Scientific Instruments, History of Science and Technology in the People's Republic of China, Museums, Borchardt Museum, Deutsches Museum, Royal Victoria Gallery for the Encouragement of Practical Science, Whipple Museum of the History of Science, Types of Scientific Instruments, Optical Instrument, Electronic Test Equipment, see also, Instrumentation, Instrumentalism, A Philosophic Theory, List of Collectibles, see also, tron, a suffix to denote a complex scientific instrument, like in cyclotron, phytotron, synchrotron. References